Well, hello again and welcome everybody to the fourth, and I apologize for the delay, but the fourth episode of the Data Miners Union. And I have with me today a special guest to help me with today's presentation. With that being said, I would like to introduce my special guest, Salimah K, fellow nerd extraordinaire.
Hi everyone, welcome to the fourth episode. I hope this will be a very enlightening episode for you.
I'm certain it will be an enlightening episode, especially with you to bring personality quotients above normal.
Yes, I'll be throwing in some random quips and comments, as well as guiding you through a few options.
Yeah, and more importantly, keeping me on track and making sure the right things are said, which is good.
Yeah, or encouraging the wrong things. Let's see how this proceeds.
I like encouraging the wrong things. Let's see where that goes.
Okay.
So what are we doing today? And by the way, feel free to follow along with us on GitHub. I have posted today's example files up on the GitHub, and I can show that to you a little bit later how to access them, including the fourth episode we're doing today. And what are we focusing on today, Salimah?
Today we're looking at how to append, data sources from various documents. How to organize it in a way that's easily understandable and kind of merges all data in the right way, as well as drop-down columns as well.
Yeah. So what we're looking at today is a fairly common exercise. Anybody who's been doing data mining ever, more common than not, you're probably pulling data from CSVs or Excel files or Word documents, PDFs. But we're going to do two episodes. We're actually going to split this one into episode 4 and episode 4.5 or 4.2. Don't know what I'll name it. And the first one is just how do I grab data from 100 files or 10 files or 10,000 CSV files?
Mm-hmm. How do you mine for gold, in other words?
Yes, how do we mine for gold in them dar data hills? I may keep that, I may chop it. And the first half of the episode we're actually going to do is, I don't know if you can see my mouse, but maybe I'll highlight it, is we're going to mine into, I think I've got 10 sample files that are formatted roughly the same, where we have some header information at the top, which is always in sort of a row by row level. First one's going to be an ID, second, third, and fourth. There's discrete values that stay the same for the entire file. And then below that, always for these files, starting on row 10, is we have the measurements for those features. Again, we're going to assume for this batch that the files, all 10 of them, or 10,000 of them, are consistent in at least this structure. Future cases, maybe we'll deal with more advanced where the headers might not always be in the 10th row. That's not today.
Okay, it'll have to be next time. We'll keep it simple for now.
It'll have to be some other time, yeah. Yeah.
Keep you guys in the mystery.
Yeah, and for some of you guys who are listening, you might pick up on, Salimah and I have had this conversation before because we've recorded this before, and then went down rabbit holes after rabbit holes, which was fun in itself, but we're re-recording now. So the goal for the first video is we're going to take and ignore the first 10 rows, and we're actually going to dive down into the columns and append that from the 10 files. Video 2, we're going to come back in and pick up and reclaim the data that's discreetly held within the headers for all 10 files and pull them out. So if you're interested in that, stick around. This is actually a request sent to me by one of my coworkers, Kong. I'll say hi to him. So the goal that we're going to be going for is extracting the data out and turning it into a wide table with controlled headers, stating the source, what file it's coming from, reclaiming the two columns here, the relative position and max depth, which are the ones that start down here on row 10. And at the end of video 2, we're also going to reclaim some of the header information and turn those into column values that repeat for each row.
So here's our Excel spreadsheet of one of the data files, just to give you an idea of what that looks like. At the top you can see it gives you the ID, the start distance, the max depth, and min depth. The columns themselves are the profile position and max depth. And we have about 10 files that look identical to this.
We have 10 files that look identical. Yes, we have 10 files that look identical to that file. And I've got them stored into the same location. Just for ease of use for the example, there are advanced techniques where we can actually find them scattered throughout an entire U drive if we wanted to. But for this purpose, all 10 or 10,000 are going to be located in the same directory, so they're easy to find.
Yes, beautifully shaped and sized for perfection.
Beautifully shaped and sized. These are all flat files. They're not round files or star-shaped files. And our goal is to grab the information from all 10 or 10,000 files and put them into a single table. Now I'm going to challenge myself and try to build this from scratch. Salimah, what do you think are our odds of that?
I don't know if that's a good idea, Colin.
You don't think it's a good... I can't do it from scratch? You don't believe in me?
Sounds like we're threading into muddy waters.
Oh, I believe in me, so even if you don't, I'm going to try to do this from scratch. All right, step 1, new notebook. Yay, we're off to a good start. With PowerQuery, and this is actually where we're going to start off, anything I show you in PowerQuery, you can absolutely do in Power BI. It's the same engine behind the scenes. I just prefer showing things off in Excel because you have a table right there and ready to go. As most of you are probably well aware, PowerQuery you can connect to hundreds of connectors right now, I think. It's actually very close to 100, if not more. The specific one we're going to be going for today to start off with is actually from file and from folder, because we want to grab data from the folders. And we're going to browse to the path of the folder. Now I'm going to be lazy. I'm actually just going to copy the file path to the folder we want and paste that in here. And PowerQuery and Power BI, the more recent releases, I think a little while ago, will actually recognize that you have all of the same types of files in here, and even give you an option down here at the bottom. In addition to load, in addition to edit, there's actually a combine option.
Combine.
So used to be, if we wanted to combine data from a lot of Excel files, we'd have to build the next several steps manually. Not painful, but it's not something that's intuitive. This takes those next 10 steps that even if you knew what you were doing would take 15 minutes to do, and makes it a 30-second ordeal.
So how is this different from append, or even, I guess you could even merge it, depending on it. Why would this be preferable?
Actually, it does use the append.
Okay, so indirectly.
It indirectly, what the combine does is it creates a function that opens up a file, looks into it for content. Inside the function, we define how it changes or transforms that content. And then at the end, returns the result for that one file. And then all of the other files get iterated through with the same function, and all of the results end up being appended together. So at the end, all of those files get sent out into a single table.
Okay.
So let's do with the combine, and I'm going to do combine and edit. Actually, no, I'm going to combine and load. Let's just shotgun it and see what happens.
Yeah.
Do you want to do that?
Oh yeah, let's do that.
When you hit combine and load, or even combine and edit, first thing it's going to do is recognize that you've got a lot of files in here. They might all be the same. If they are, that's great. It's going to pick one of those files to be its sample. And that one file, you can poke into it and go, how many data tabs do you have? How many tables do you have? And you can start using this first file as an example to go, okay, this is what it's going to pull open and look out. Down here I'm going to check skip errors, just in case the files aren't formatted the same, some are maybe opened by other users, just skip the errors.
Cookie?
Oh, I love a cookie.
Yeah,
yes.
go for it.
This is a good time for a cookie break. And I haven't done anything special here other than combine and load, selected the table I wanted, and hit combine and load. So with our fingers crossed, we can see here on the right-hand side, it's actually created 4 things for us, and it's also loaded in all of the files.
Yeah.
And I'm not even going to edit this. This is going to be real time. That's how quickly it iterated through those 10 files. And we'll cover what these 4 things up here are that it created, but let's look at the 5th one, because that's the output of everything. Salimah, what do we see here at the top?
So at the top we have some information like ID and start distance that applies to all of this data set. But basically it's at the top, basically 7 columns right now, 7 rows, sorry.
So
how we want to delete, if we want to append appropriately.
Possibly. No, so I'm going to look at the original data file, and we see there's actually 2 columns. and I come and look at the output, there's 3 columns. And this already was created for us by the system. What it does is it retains a source column. So this actually tells us what file each of those row elements came from. And we can see here, there's a complete list of all of the files. So this is how we know it iterated through. So all of these rows here are actually from copy 4 of the file. And down here we can see where it has transitioned. And we start seeing a repeat, well, not necessarily a repeat, these are different values, but where the structure itself starts to repeat again. And we see copy 5 had the same transformations applied to it. And all 10 of those files at the end became appended together. And this is already kind of useful. Frankly, we could probably stop here, and most data scientists can just parse out what they want manually afterwards. But I'm lazy. How about you?
Occasionally, I can be.
You can be lazy?
Occasionally.
Yeah. See,
this is one of those times.
I was lucky. I had a professor in university who professed that laziness was the engine of progress. And if you wanted to do things the hard way all the time, you have a much higher work ethic, but you're probably not very smart. So he encouraged intelligent laziness. And thankfully, I'm intelligent enough to afford to be lazy in some cases. So I'm going to dive in and show you a few of these tricks that are happening over here, what the PowerQuery tool has already done for us. So I'll just open up the editor here and we'll see what the final result looks like. And let's take a quick look. We've already seen the results. This is what we've got coming out into the sheet. Let's take a quick look at what some of these values up here are. This one here, the sample file, it's exactly what it says it is. It's a copy of the first file we told it to take as a sample, just so that it knows what structure of the file it is it's looking for. Then we have a parameter. This was created again for us, and all that parameter is doing is pointing to the sample file. Why is it doing that?
So we can change it if we want.
So we can change it if we want to. And then we get down to the real meat. Down here we have the 2 last ones. We have the transform from sample from file. Again, this was created for us. And this is just like a regular Power Query. But if we go up to source, we can see the source of the workbook is actually from sample file parameter 1. So this is where the parameter is being handed along. We come down to navigation, and this is this list of steps over here that get applied to every transformation that we want. All of that then gets wrapped up into this function. Anybody who's done math or anything else recognizes f of x. This is actually a function where in the parameter field here, we can supply manually or supply through another query call the source of each different file, and what it'll do is repeat every step that we have written in the transformation. So if we change the steps in the transformation, the results where all of those files get appended together will get changed as well. Have I lost anybody?
I'm still with you.
You're still with me?
Yep.
Maybe it'll make more sense if we drive home a little bit what change we can possibly make. So I said for the first video here, we're actually going to ignore the first 10 rows. So let's do that. Let's see what happens. Again, let's take a look out at what the output of all of that function is. We still see the headers up here, and we'll see repeats of the headers down where the other files start becoming appended. So let's come up to the transform. This is what the function will repeat every time for every file. And let's just remove the top rows. In this case, let's remove the first 9 rows. So I now have some headers, and let's actually promote the headers. So if you haven't seen those functions before, this is the first time seeing them, those functions exist. But we can see here in the transform from sample file, it's added 2 new steps, and we end up with a result where I've got headers that are named and the rows with the values, but none of the headers. So I can again come into sample files, and it's not working right. Why isn't it working right? It's actually this change data type, because it's trying to change the data type of column 1, but that column 1 doesn't exist anymore because we've named it. So I can get rid of the change data type. And now we'll end up with, and in fact I'll even close and load and refresh all of that. The output now excludes any of the header information. We still have all 10 of our files have been extracted, but the only information we have is numeric values. In fact, we can tell when we do a filter, it's not seeing any of the text values from the other headers.
What if you wanted to delete that first column? Would it make a difference or no?
Deleting the source column?
Yeah.
Yeah, you can actually do that. Not necessarily within the transformation, because the transformation function, all this is doing is saying, what does this one file return? It's actually out here in the sample files level, where if we go back to source, we'll see this is all of the files that were in that folder. The next step it does is it invokes that custom function, and that's the one that we've been playing with up here, where it creates a new column and calls a function and hands along as the parameter the path of the file.
I see.
Then we rename it, and these were already created for us by the system of that initial call. It even removed the columns, so in this step it kept the source column, removed errors, and then it expanded the table. So that's all that step was. If we want to remove the source column, what we can do is actually change that step in the query, get rid of source column, and we end up with it's gone. So I can just hit close and load, and the source column's now gone. I don't recommend that step, because if you're pulling data from tens, hundreds, or thousands of files, knowing what file, what data came from,
Yeah.
usually something you want to keep around.
Right.
So I'll actually just pop back in there and bring that back out by hopping into the step and editing it so I get my source names back out. And we'll just close and load, and that'll execute by again. How quick is that though? Like it just popped into 10 files, pulled all of them out.
Yep.
So I think that's actually where we're going to stop the video one, is mining into the data, knowing what it does to help create the functions, and doing the simple thing and keeping those two columns.
Yeah, I think that's a good start.
That's a decent start. So I'll pop back into the PowerPoint here, and I'd like to say thank you everybody for sticking around for this video. Stick around for, or come back for video 2, where we go into a little bit more detail about how to pull back that header data and put it into the table. So thank you for coming.
Thank you. Happy mining.
Happy data mining.